Okay, so again, next week we'll have the meeting on Zoom, unless there is a demand for some of you to meet here, then we'll accommodate this. And it's Hanukkah. Officially, I think you're not supposed to go to have classes after 4, but I really would like us to meet. Anybody has an objection? It's Zoom. You can do it from home. You can light the candles and grab a donut and watch the class. You don't have to. You can present from home from your laptop. That's, if you want, just let us know and we'll arrange this. Okay. If it's done, by the way, Khaled, it will have to work from here and not from my laptop, right? So you'll have to get help from yourself. Okay. So if there is, please contact me and Khaled in case you want to present physically from this room. Okay, but we can always share screen from home and then present from home as well. Okay, so we decided that we are going to continue as usual. We are going to meet next week at 7 p.m. by Zoom. Any other comments, requests? Okay, so let's start.
I'm starting.
Yes, but for some reason the sharing is not working. Just a minute.
You want me to share?
No, just a minute. Okay, so the first speaker is Coral. Coral, you are presenting from home?
Yeah.
Oh, I didn't realize this. So let me unshare.
I can share by myself.
Yeah, that's what we'll do.
Yeah, okay. So please stop sharing and I will share.
I need to control here.
I think it will be more comfortable if I will share. Just, yeah. Okay. Just a second.
Okay, you can share your screen then.
Yeah, of course. Okay, do you see?
Yes.
Okay, so good evening, everyone. Today we are going to speak about a topic that I'm very interested about. And we are going to speak about a mistake that the very and smart Einstein made. Still there, when he was making this kind of mistake, he was very smart. We'll speak about that it's not a real mistake. It's more an incorrect assessment. And okay, it's about gravitational lensing. Maybe some of you heard about it, the physicists, maybe. So you can interrupt me, ask questions, and the information that you know, feel free. We're going to speak about an article that was published in Nature, at Science, sorry, by Ren and his colleagues at 1997. And this paper is about a paper that Einstein published at 1936. So let's see what it is all about. And the paper is called The Origin of Gravitational Lensing, a postscript to Einstein 1936 science paper. Let's see. Okay, we will start with...
Coral, can you please switch to presentation mode?
I see it in presentation mode. You don't?
No, we don't.
Okay, that's weird. And maybe because I have two screens, you see one and I see the correct one.
So in this case, there is...
I will switch.
On one of the screens on the top, you should have double arrows that you can switch with.
Yeah, now you see?
No.
What?
So maybe
what
get out of presentation and get back in again.
Okay. I'll do it again. Sorry.
Show the window instead of the presentation.
Okay, now please tell me what do you see?
Now it's better. Thank you. Go ahead.
Okay, so the first one was this. You saw it?
Yeah.
Okay. So let's speak about a favor for a friend. Okay, I took this image from Einstein's paper, and he wrote like that. We can see the name of the paper, lens-like action of a star by the deviation of a light in the gravitational field. We can see that under this line he wrote some kind of apology. Let's see. Some time ago, Ruby W. Mendel paid me a visit and asked me to publish the result of a little calculation, which, oh sorry for that, which I had made at his request. This note complies with his wish. Okay, so we can see that Einstein, what do you think? He wanted to write this paper. What do you feel about that when you read this kind of thing in science paper?
Sorry,
what does it make you think?
You're asking the audience?
Yeah.
What was the question again?
I'm asking how it makes you feel to see this kind of, it seems like a kind of apology in science paper. Do we see things like that these days?
Sounds like a disclaimer.
Like a disclaimer, yeah, something like that. Okay, so what it makes us think about the theory? You felt good about it? Okay, I will continue. Okay, you don't have to participate if you don't like. It's okay. Okay, so an important result from the general relativity theorem is that light bends in the gravitational field. Why? Okay, the general relativity theorem said that, let's say, the more massive an object, it curves the space-time more, okay? So if the space-time is curved and light passes through space-time, it will be curved also, right? So the conclusion is that light bends in a gravitational field. That's the main notion of gravitational lensing. And this is what Einstein wrote at his paper. So in this image, we can see a position of a star. We can see ourselves at Earth. We can see the sun as a massive object. And we can see the appeared position of a star. We see like a virtual image of the star that was behind the sun, okay? So let's speak about it more. We'll continue with something some more apologies, then we'll speak more about gravitational lensing. After his article was published, Einstein wrote to it. I'm sorry, I'm just moving you from my window so I can just read what I wrote. Okay.
But do you know?
So after his article was, what?
Is there any reference in the literature why Mendel really wanted Einstein to publish this note?
He wanted.
No,
okay.
Why did he?
Why did he? Okay, from what I read, he was an enthusiastic electrical engineer, an amateur. I don't know what was the relation between him and Einstein, but they were not colleagues or something like that. But I don't know really more than that, but he just knew his calculations.
But it seems like Mendel was putting some pressure on Einstein to publish this short note.
Yeah, he did, but I looked for his relations with him.
Seems like Einstein gave in. Basically, there was some pressure, he gave in, and then he wasn't sure if it's good enough, and he was apologetic.
Yeah, but I didn't read the slide yet, so let's be a bit patient. So After the publication, Einstein wrote to the science editor an incorrect assessment of the value of his research. Let's see, he wrote to him, "Let me also thank you for your cooperation with the little publication, which Mr. Mendel squeezed out of me. It is of a little value, but it makes the poor guy happy." Okay, so we see that he wrote this thing in the paper itself, and afterward he wrote it to the cooperation, to the editors, and he continues with his line. Sorry, I don't know, I'm a bit excited from this presentation, so I'm sorry. Okay, we can see a sketch. That's okay, yeah. We can see a sketch from his notebook, from Einstein's notebook. Here you can see his handwriting. He wrote that at 1912. It was 3 years before the publication of the general relativity theorem. Okay, 3 years before the special relativity theorem was published, and more than 20 years before he published his article about gravitational lensing. Okay, interesting. So we can see this, we can see this kind of sketch here. And when we zoom out, we can just see that it's the model of gravitational lensing that we can see here. We have an observer. We have this lens that's made by a massive object, and we can see the source of light, and there are different distances between the source of light to the lens, and from the lens to our eyes or our detector, our telescope. Okay. Also, Einstein wrote in his paper that there is no great chance of observing this phenomenon. He said, okay, even if it's true, we won't be able to observe it. So it's a nice theory maybe, but nothing more than that. Isn't it? Okay, so about gravitational lensing. Today we know that we can use it, even we can observe it. How? Not with some small stars that act like a lens, like our sun. With galaxies, and even more, we will speak about it in 2 slides ahead. So galaxies can bend the space-time enough for us to watch some images of a far source of light, like old stars, supernovas, and even quasars, that they were just made in the universe at its early beginning. Okay, it's like 11 billion years ago, billion years ago. In Hebrew we say milliard, in English it's billiard, so sorry if I'm mixed. And if the symmetry of the object is very round, and also it lays exactly behind the lens from the observer eye, we can see something that looks not like an image, sorry, we can see something that looks like a ring. So here we see real images from, it's almost a symmetrical ring, but those are called Einstein's rings. And you can see the right one, it looks a bit like the cat from Alice in Wonderland. So I put this image for you, and it was took by a Hubble telescope. Was taken. Also, galaxy clusters can act like gravitational lenses. Okay, they are not really one next to each other. We know that they are very far, maybe 100 light years from one to another, can be more, can be less, but they act like a cluster. What does it mean? It means that when light comes to the gravitational field from far source of light. It is bent, and then it comes to our eyes, okay? So Einstein, he thought that it can be, this phenomena can happen only if we move, if the light moves next to a star, but he didn't think outside of the box, let's say, or something like that. He didn't think about galaxies or clusters of galaxies. And even we know that the mass of a big portion of the mass of this cluster of galaxies is the dark matter. So it's not only the mass of the galaxies.
Okay.
Questions?
Right, or you want
I heard the question.
Like she just mentioned that he thought that it can't be observed in the.
I can't hear.
So come here. The microphone is here.
But the thing was.
So there is a comment. Let's hear the comment. Yeah.
Yeah.
You mentioned that he thought that it can't be observed in galaxies, but he knew that it can be observed, but the only thing he was not sure about whether it is pronounced enough so that it can be visibly observed or not. Because when he published his relativity in 1915, right after his publication of results, these things were proved when the Arthur Eddington proved the results for the bending through sun. Because at that time, they were not very good instruments, so they could not go for galaxies and stuff. But during the solar eclipse in 1920, they observed the
it was in 1990.
Exactly.
Yes. In the solar eclipse that made what was his name?
Arthur Eddington, Sir Arthur Eddington, actually.
I don't remember. Yeah, there was some, okay, let's say it was not his, let's say that even before Einstein made his calculations and everything, even Newton knew that light will be bent near massive objects somehow, but his calculation and model was not accurate. Einstein's model was accurate. And we know that in 1919, there was a solar eclipse that shows that the general relativity theorem is correct. And we know that this gravitational lensing is a result. But people really thought about this gravitational lensing and try to measure things with that. We will speak about in one slide. Actually, at this slide, we're going to speak about the consequences, what we can measure, new things with this gravitational lensing. People did that only after Einstein published his paper at 1936. So the solar eclipse, it was nice for general relativity, but it didn't give the real value of this phenomenon that Einstein didn't think about it before, okay? And this is why, if it was so dramatic result, then Einstein wouldn't write all these story papers after he published his paper, right? Okay, so now I'm asking you all, can you think about applications for the gravitational lensing? Maybe you heard about some.
Search for dark matter.
So there is one answer, search for dark matter.
That someone wrote?
No, maybe you can measure mass of stars.
Measuring masses of stars.
Okay. What do you mean by measuring?
I mean, if you observe the bending of light, you can try to estimate the gravitational force that bends it.
Okay. So as we saw at some of the pictures I showed you, if we have a very, very far star, okay, maybe we can't notice that from the direct path of the light that comes from it to our telescopes here. But if we observe from a place that between our observer and this kind of star, there is this gravitational lens, it can magnify it, okay? Like lenses do. The metric is a bit different. Okay, it's different than our optical equations that we know, different, but it's but also we have magnification. Okay, it depends on the distances and everything from the lens and to us. So we can observe virtual images of stars that we can't observe from other places. So we can send our telescopes like Hubble and the new one, James Webb, to different places in our solar system, even outside of that. And from there they can observe they can be in the path of different lenses, okay? And observe other things that we can't see from here. And moreover, can you think about something else also? Any ideas?
Not here. The people
Okay.
at home can participate.
Yeah. Okay, so there is another thing that scientists did. There was a time that we observed 2 supernovas at the sky, okay, in some cluster, near to some cluster. And from the symmetry, physicists knew that there was supposed to be another one, but they don't see it now. It's supposed to come. So you know what a supernova is? It's like a born of a new star. It's when the star ends his life and he's massive enough, it just kind of blows, and we can see some, let's say it is very energetic and it can be observed. But we know to observe something in the sky and say, okay, this is supernova. But the born of a supernova, this is something that scientists could see with the gravitational lensing, because they saw some virtual images, and you can and we know that the path of the light of any of these virtual images was different to our observatory. So if some light came from some place to the observatory and some symmetry, another image can be in some other direction. So they collected the light with Hubble telescope to another area near this cluster, and saw a third one. So the supernova, let's say at real time, okay? So it's also very interesting to measure new things and get to know how, like the, I forgot the word.
Hebrew.
Okay, okay, I forgot this word, but to learn how the evolution. Okay, I just wanted to say evolution.
Okay,
to learn about the evolution of the stars.
If I understand correctly, the last example or the last application is when you have coincident detection from 2 different detectors.
Yeah, of course.
Okay, so you have time.
When you saw something.
Since it's a temporal signal, you know exactly the time, and you see it in 2 different places, then you know that you have been.
Yeah. Yeah, you can't really know where, in which time the last one will come. You don't really know the path of the light, but you know that it will come. So you can wait 2 days, a week, even a year, and then you will see that.
Okay, great. Since we have 2 more speakers, let's speed up.
Yeah. So that's only the image from the James Webb telescope that you can see. Sorry. And all of these lines are the gravitational lensing, and here we can find the cluster. So thank you. I hope it was interesting.
Excellent. Any questions? All right, great, thank you. So let's now share again the presentation here.
I think one more thing there.
Yes.
One more thing there was, it was written in general relativity theorem. General relativity is not a theorem, it's entire theory, actually. That can be
Theorem versus theory. Yeah, okay, no problem.
Switch slides here on this. Yeah.
Okay. So the discussion the thing I want to show you today is a paper that was withdrawn in 2013. And it's a paper about chopstick nanorods. It's a tuning angle between pairs of nanorods, and it's not, in its base, it's not a subject that is in any way close to me. It's not something that I chose because of how interesting it is to me, but more because of how it's an example of how easily someone can put in, it's not a mistake, it's a deliberate misconduct.
Fraudulent science.
And it's so on the nose, it's so there, and all you have to do is just look a little bit and you see it, and it was still published in a very major paper. This was published in Nano Letters, and it was really quick. It was really quickly withdrawn, but let's first start by talking about what is chopstick nanorods. So we'll give a quick explanation about what it is. Again, it's not my subject, it's in chemistry, I'm a physicist, but I'll try to be as accurate as I can, and if you know better than me, you can correct me at any moment. So what I wanted to show you here, you can see the picture here, we will show it again later. This is the main result from the paper. And the paper, what he did, they were trying to demonstrate the ability to selectively deposit quantum dots and gold nanorods dimers onto parallel, perpendicular, and intermediate configurations. And they claim that they managed to do it pretty easily. So let's start by what is a gold nanorod. You can see an example of it right here. It's a small rod in the scale between 1 and 100 nanometers. It is usually chemically synthesized, and what they usually do to arrange it in particular manners, they use an AFM to move them one by one and arrange them in any way they want. And it's a very lengthy process when you're trying to arrange a lot of them. But what they claim is that they have a completely different method, which is an electromechanical method that does not depend on the substance itself, or it could be plastic, not plastic, but it could be like an organic material. It could be a metal like gold, and it could be anything. And the method they use, which I will shortly explain, it's called electrospray differential mobility analyzer. And the reason why they care about it is because apparently, you could absolutely tell me, explain it to me much better, but apparently in photosynthesis of some bacteria, they have pigments that are actually arranged in those rods. And in the cell, they are arranged in a specific angle, and this angle actually matters. So being able to decide the angles between the rods is a very important issue in the study of photosynthesis.
Well, in general.
In general, yeah.
To do bottom-up assembly of nanoparticles and have control over, orientation is very important. So people are trying all kinds of methods.
Yeah.
So I guess this paper is about arranging nanorods in chopsticks.
In a specific angle. So,
just because they want to say we can. Okay. Well, no, look, DNA origami, or nowadays even protein origami, it's arranging matter on the nanoscale, bottom up. Okay. If you can demonstrate that, it has to be done by self-assembly methods. All right. This is not that you're going to manipulate one by one. You want to have bulk approach to make lots of chopsticks or anything else that you want to make. That's just you want to demonstrate that you are able to put things together in a very defined orientation, because that will be a building block towards something more complicated. So can you do this by something? That's basically the topic.
Yeah. So let's quickly talk about what is electrospray differential mobility analyzer. Well, the part of an electrospray, I don't know if I can show, it's actually a video, which will take 30 seconds. It will take 30 seconds and it will do that. It will definitely be better than what I can explain, because I just want to show the first minute.
Electrospray starts with a liquid formulation.
Can you hear it?
Pushed through a capillary at a precise and constant flow. When an electric field is created by wiring the liquid to a high voltage, the meniscus rapidly turns into a stable cone, out of which a jet of liquid emerges and becomes a stable spray. This is the cone jet mode. Primary micrometric and highly charged droplets are formed in the jet. Due to electrostatic repulsion, they break into finer charged droplets, which themselves break into smaller and smaller ones, thus becoming nanometric.
So this is basically what the electrospray is used for, is to create those nanometric droplets that could, some of them could include a nanometric material like a nanorod, and this way you can spread it in a very controlled environment. But the other part of and for some reason now it's not, okay. The other part is the differential mobility analyzer, which is basically a technique to arrange your the result from the aerosol outlet from the electrospray in a very specific manner. You apply an electrostatic force, and depending on the mobility, which is a particle velocity divided by unit of external force of each and every one of your particles, they will move a different direction, and you can recollect you can have different areas with different mobility nanoparticles. So they claim in their work that they manage to create those varying angles and coat them in some sugar or something like that, and then run it through this technique, and then you can see the spread of the and you can actually see the spread of the different orientations depending on the mobility diameter. So they claim that they managed to do a method to separate the nanorods depending on the angles. And they show this beautiful picture right here. You can see, if you look from here, it looks perfectly fine. But once you start looking a lot closer, and this was a work that was published on a site called Chemistry Blog by some guy named Mitch, who read the paper and just said, guys, there's something not right here. Look at the images right here. You can definitely see that someone just cropped it in, it didn't even try to use a Photoshop or he just cropped it with MS Paint or something, placed it one on top of the other, and that's it. And it passed through his professor. He was a PhD student. It passed from a professor, the other writers on the paper, and everyone else. And apparently, it just got published like this. It's a very prestigious paper, which is Nano Letters. So the paper was eventually obviously removed after 2 days after the publication of this thing.
How long does it took from publication until somebody noticed, and then?
A few days. It wasn't.
It was very quick.
It was very quick. Apparently, a lot of people noticed it, but this was the first one who gained traction. 2 days later, the paper retracted the letter.
Because usually it takes years until.
It was so obvious, though. It wasn't even a question. And even another paper that he wrote 2 years before that.
Maybe doing what he claimed he could do was like overwhelming.
Yeah, this is why people look. I mean, we are coming back to the main idea. You want to self-assembly from bottom up, right? And why should that electrospray do this? What are the chances that the electrospray will somehow arrange those diameters?
So then you get suspicious, right?
Yeah. So, okay.
It
sounds terrific, but okay, let's look at this. This doesn't make sense, right? Then you find
yeah, but it's not like they even try to hide it too much. It just it's crazy how insane it.
Well, I think this is common to all the cases we went through. Somebody gets insane, right? I mean, I cannot explain the personality of someone who will do
Yeah,
this.
yeah, but it's not someone like Sean, who's a known professor. He's a student. He's a PhD student.
But what drives a student to do that?
That's a good question. Yeah. So the aftermath. There was a internal investigation in the University of Utah, and they concluded that all the images in the paper were manipulated. So the graduate student, I'm not going to try to pronounce his name, but
It's like an Indian guy.
yeah, but I'm not going to try to pronounce it. But they found him responsible, and only him. And the university denied his doctorate. An interesting thing that I found, by the way, is that there is a book called The Delivery of Nanoparticles, and he's still there, and you can still buy this book if you want. I'm not saying, again, I'm not claiming that what is written in this book is wrong, because I looked through the chapters and it didn't talk about anything about those angles.
As we discussed last week, people still don't want to vaccinate because of...
Yeah, so this book,
it propagates and it stays, right?
Yeah, so you can still buy this book if you want to and read this chapter. Now, the rest of the authors were found not responsible, including the professor who was working with him. He was a co-author. He was a co-author on the first paper as well. Yeah, he was the last. He was his professor. He was the one who did his work. And the university said that the level of the oversight was not deemed to be poor enough to continue to constitute research misconduct from this professor. And he says any additional action against this professor would be taken by the school's chemical engineering department, but nothing happened. He's still a professor there, if you're wondering. Now, so basically this is the talk, but what I wanted to say is that it sounds like it couldn't be just a mistake of 1 or 2 or 3 people. It sounds like there was a systematic problem here from his professor all the way up to the paper, of people who simply did not look at the data. All that needed to happen is for someone to take this paper, to look at the data and say, this can't be, this is not even a good Photoshop.
And as you said, he did not even try to remove the background by Photoshop or anything.
Nothing. So it's an interesting subject. All you had to do is for someone to look, and it wouldn't have been published.
But again, the whole question about peer review. And
yeah, exactly. Peer review, his professor.
The professor goes over the data, and I mean, it fails in every step.
Yeah, so that's it. Thank you. Any questions?
I think by now you can see that there's some kind of a common thread for all the fraudulent science cases we have. Somebody needs to be over-motivated that is willing to do this, and then all the rest just don't notice.
I think the interesting question is how common it is and how many of these papers are out there that we don't know.
Still, that we don't know. So, just roughly speaking, about 15% of population are crooks, right? Willing to cheat. Okay. So, a big surprise. Scientists are not.
It's mostly in life sciences departments. Because whatever we can see still mostly are life science people.
It's really, we need to, I mean, the topic really.
I think in engineering it would be easier to do that without anyone.
No, of course, if you put some effort to this.
Yes.
No, I mean in the area of engineering research.
Yeah,
because you can.
But listen, the guy would take those cropped images and manipulate them a little bit with Photoshop, and nowadays maybe a little bit with AI, and then you can produce data that looks really real. He was totally stupid, right? He was just using rectangular cropping device, and it wasn't perfect. So it faced it. That was it. This is so stupid. If you put your mind to it and you want to cheat, you can do much better challenge it. And then it will be much harder to find.
Some people want to
So, but the point I want to say, we are now deviating from science altogether. It's criminology, right? And what drives people's personality? And why do they think that they will not get caught? And what will be the benefit?
In this case, it's a very good question. Right?
Yeah, I mean, the guy was totally stupid, but
if we're starting to talk about criminology, we also can start the discussion of how to stop it, like the law system try to stop crimes.
But we are doing this, right? We have now all these rules, open science, all kinds of.
Yeah, but I'm not as a master's student. I don't know what the consequences are if they cheat. Maybe it can drive someone to cheat if he doesn't know what the consequences are.
I think that it would be maybe prudent of universities have on the first semester of a graduate program to have a course on ethics in science. You know, when we have this year. But it's important, and just the purpose of this course is to show you that it's actually quite good. It's there. When I started to look into this, I was shocked because you find all the place. And when we are trying to think that scientists,
still there are cases like the one he just presented. He's still a professor.
Yeah.
What happened to?
But that log who was Sean's advisor, he was promoted. He got a big position in Switzerland.
Yeah.
So none of these cases so far, if the misconduct was a postdoc, a student, and there was a mentor or somebody, higher up, none of these cases had actions taken against the mentor. None of them. He didn't know, but he wasn't careful enough to look at the data, or he wasn't careful enough in instilling in the culture in the whole group that things like that will not be tolerated. But still, if you have a very, very motivated student who is willing to do this and is willing to do a better job, when you do it, it's very hard for the mentor to.
Yeah, specifically in this case, some people said that this should not remain in the range of the University of Utah and should be investigated federally. But they started looking into whether he used federal funds or something like that, and because it didn't use federal funds.
Yeah. So indeed, that usually when you run into misconduct, so the journal editor will go to the head of the university, and then the university will conduct it first,
which is also a problem.
And implement some. They will have conclusions or fire the professor. They'll do something. But indeed, if the work was funded by NIH, NSF, DOE, there will be investigation by the funding agencies as well, and some sanctions.
But I think it should be. It can't remain only in the realms of the university, because you see,
usually have the interest to shut it down.
Yeah, because the professor is maybe is a friend of I don't know. Plus, they have an interest.
Because also when that happens, sometimes this professor sues the university.
Yeah,
it's the U.S. society is very litigation oriented, so university also wants to protect their interest and not get sued. All right, great, thank you. The last presentation. This is Michal.
Okay, so thanks. Okay, I'm going to present a case of fraud, scientific misconduct, and bioethics law violation in human stem cell cloning. And if I will have time at the end, I have also two interesting cases I would like to briefly go over. So let's talk about this case of cloning. So first of all, so we're all on the same page. What is cloning? There are several reproduction processes in nature. We are familiar with the sexual reproduction process as mammals, but there is also the cloning process that is that exists in nature. However, if we want to copy this cloning process for mammals, for example, we need an artificial process, as can be seen here. So for the cloning process in mammals, what we do is we take an egg cell from some female individual. We extract the nucleus from the egg cell. So now we have an empty egg with no genetic material. Then we can take a somatic cell, a cell with full set of chromosome from some donor individual. And by combining the somatic cell with the empty cell, we get a fused cell with full set of genetic material that is an exact copy of the cell donor. Then this cell divides into an embryo as it normally does. This embryo can be implemented in a foster mother, and after a pregnancy period, we get an offspring with the exact same genetic material as the parent. Okay, in this case, can you see the mouse? Yeah, so in this case, the parent is the white-faced sheep, and after the cloning, we get a cloned lamb, which is a white-faced sheep, just as the parent donor. Okay, so the first cloning of a mammal was in 1966, the sheep Dolly. I assume you heard.
66? No, 96.
1960.
1996.
Yeah, it does sound wrong. Yeah, so I'm sorry, it's probably
It's 1996.
yeah. So yeah, that's wrong. 1996. So the first mammal to be successfully cloned was the sheep Dolly. And it is important to note here that the cloning process is not a very successful one. Dolly was the first successful attempt after additional 277 attempts.
So one in 300.
Yeah. Yeah. So the cloning process has many advantages. One is the economical one. If you have a specific cow that gives a lot of milk, you can clone it, and then you have lots of cows that give lots of milk. A very good advantage. Another advantage is ecological one. You can clone endangered or even extinct species. If you happen to hear about it, there is a subspecies of rhinoceros where there are only two left female.
That's a white rhinoceros.
Yeah. So there are talks about cloning those rhinoceros.
There is already a project to bring a mammoth back to life.
Yeah, that is also the example for the extinct species.
Only female, still females left and clone. Yeah, we just still have a female.
Yeah, I think. Yeah, if I'm not mistaken, I'm not sure about the little. Yeah. Yeah, so I'm not sure about the details, but there are talks about maybe there is some sperm that was taken beforehand, and there are a lot of different methods that can be applied here. And lastly, the main reason for the big interest in the cloning field, and the most problematic reason is the human cloning. Now, you can guess why it is problematic. There are many ethical questions that can rise from cloning humans, but the advantage in human cloning is mostly for medical procedures, when you can clone and grow certain limbs or organs with the exact same genetic material as the patient you have, and then you can transplant those organs without the patient's immune system rejecting it due to it being a foreign body. Okay, so now we know what cloning is, and we can start talking about previously Professor Wang-Woo Suk and the problems in his research about human cloning. Okay, so first of all, we can understand the big problem it introduced. Professor Wang was a South Korean veterinarian and researcher in the stem cell research field. He was a professor in Seoul National University. And in 2005, he even was awarded with the Supreme Scientist by the Korean Ministry of Science and Technology. And he was considered the pride of Korea. He really was a Korean star, not only in the research community, in the scientific community, but in the overall Korean community. Okay, so let's talk about the rise of Professor Wang. First of all, in 1999, he claimed to successfully clone 2 different types of cows. In those cases, he didn't provided scientific data to back that up, but he still got a lot of publicly fame because of the economical advantages that it offered. Then in 2004, he published a first paper in Science Journal when he reported the cloning of human stem cell from 242 egg cells. Now here, both the eggs and the somatic donor cells were from the same individual, but it still was a huge discovery because it was the first report of human cloning. Before it, it was considered impossible, as primates are very complicated and no previous attempt was successful. So he was the first one to report successful cloning in human cells. Then a year later, in 2005, he published a second paper in Science where he reported the cloning of 11 human embryonic cells from 185 eggs. Here, the egg cells and the somatic donor cells were from different individuals, and the somatic cells were from donors of different genders and different ages. So it was a big leap medically, because here it showed that you can take pretty much any donor and manage to clone him, not a specific donor. Also, but by showing 11 successful embryos from 185 eggs, it showed an increase of 40 times in the cloning success rate. So it was also a huge, allegedly, leap in the cloning area. Then in the same year, 2005, he also reported the cloning of a dog named Snoopy. And due to this success, he was also appointed as the head of the New World Stem Cell Hub, an international institute that was devoted to the stem cell field. Okay, now the suspicions. Even back after the first publication in Nature, some allegations of ethical violations started to rise. The main problems were the allegations that Wang used egg cells from his students, female students, and even eggshells from the black market. Both are ethical violations that can be pretty much problematic, but still those were only allegations. A year later, one of his collaborators in the first published paper announced that he ceased his collaboration with Wang due to those concerns. And after that announcement, another collaborator admitted for the ethical violation, but said that he was the only one that was responsible, and Wang was unaware of it. So we have violations. Wang claimed that he didn't know anything about it. Back at the time, a popular Korean report show raised the possibility of those violations, but because of the unwavering support of Korean people, even the government, the Korean government, and the news media, the sponsor of this show withdrew their sponsorship, and any criticism of Wang was regarded as unpatriotic. Again, Wang was a Korean star, not only in the scientific community. After those events, Wang declared his intention to resign from most of his official posts and gave an apology, but still he claimed that he didn't know anything about those violations, and he didn't even know about the Declaration of Helsinki and why those actions were violations. After that, again, the Korean public gave huge support for Wang. Here, it may also be interesting to note that Wang had connection with the Korean government, the minister openly supporting him on a few occasions. So it can also give a little bit of understanding why it took time until those allegations were taken seriously. Okay, so those are suspicions that arose about the ethical violation in Wang's works, but there were also suspicions about his scientific methods. One of Wang's collaborator, again, I'm not going to try to pronounce it because I probably won't be able to. So one of his collaborators claimed 9 of the 11 reported embryos in his second paper were fabricated, and that Wang admitted to the fabrication in a personal discussion they had.
So somebody from his team came to him and said, well, there is a problem.
Yeah, and said, I know. At least according to this collaborator.
He did not suggest to retract the paper at that point.
He did, and Nature wouldn't allow it because they said we don't allow to a single collaborator to withdraw their.
Wang asked that, or that guy who?
Ro Sung-il, I guess, he asked Nature to withdraw the paper, and Nature said no, we don't.
Wait a minute, but Wang admitted to
no. Sorry, Ro asked to be removed from the paper, and Nature wouldn't allow the removement of a single author. And Wang said that he meant to withdraw the paper, but Nature said that they didn't receive
I'm looking at your first bullet point. So Ross Wang asked Nature to remove his name from the paper. They did not agree.
Yes.
He claimed that 9 of the 11 reported embryos had been faked.
Yes.
And when he confronted Wang said, correct, they were fake.
Yes.
At that point, Wang had to withdraw the paper.
No, because he didn't publicly admit it to the fabrication.
But personally, he did.
Yeah.
The minute he admitted, I mean, now the ball is falling. He cannot stop this.
Now we know.
I guess there is an option that he didn't admit to it.
If I'm a scientist, I committed a fraud. somebody exposes it, even if it's on a personal level, and I admit it to him, he's going to report this.
Yeah, but
Yes.
you don't know if he told the paper the reason why he wanted to be.
No, he did not. But on a one-to-one, now one knows, somebody knows that the paper is wrong.
The way
You're asking why one went on with it?
Yeah, I just don't understand his response.
the way
He
I
was
see it,
confronted by a coworker, and he said, "Yes, it's wrong," but he did not do it.
the way I see it,
Might have decided, okay, let's decide between us.
Yeah,
To go there and tell
maybe
everyone.
he was trying
Maybe.
to cut the deal. Yeah, I don't know.
I guess that is one option. The way I see it, because of one being a public figure, it's different because he had the support of an entire country.
He thought he's strong.
I guess,
He can
or
do whatever he
even,
wants.
or maybe he was even afraid of the backlash after he would publish it was fake.
Yeah, but still,
I
I
don't
mean,
Yeah, it's
there are
weird.
some missing points here about this first bullet.
Yeah, I didn't
Yeah,
write everything.
it's not the
There
full
was a
story,
lot of
yeah.
data.
Okay.
Okay, so after this collaborator
Raise the
claimed,
concern.
after he raised the concern, several prominent scientists in the field asked for Wang to share his data to an outsource in order to validate the results. So after all those allegations, the university indeed opened an investigation against Wang in 2005. The initial finding of this investigation were that indeed 9 of the 11 embryos were fabricated, and one claim of using only 185 eggs was false. So the panel stated that this misconduct is a grave act damaging the foundation of science, but those were only the initial results. After further investigation, the final result in 2006 determined that all 11 stem cells were fabricated and Wang used at least 273 eggs. Also, Wang claimed that he didn't coerce his student to donate eggs and didn't use eggs from the black market was false. He knew about it. He even gave donation forms to his students, and in one case even went with one of his students to the donation process. So we have scientific misconduct, and we have ethical law violation. The panel stated that actually both papers were fabricated. And in conclusion, they stated that this misconduct is an act of deception targeted to both scientific community and general public. Now, an interesting and quite the irony in the fabrication is that Wang didn't find human cloning, but he did find in his results a different reproduction process, a parthenogenetic process, which haven't been shown in humans before. So he could have published the results as they were and still get fame because it is a new process to find, but he claimed it was cloning and fabricated the results in order to assist.
And what was the reason?
Claim.
I mean, he developed a new method for cloning, but was claiming that he got his cloning results from an old method, an older method.
Not a new method.
But
They
he
didn't.
did not publish a new method. What was the reason?
I think they didn't even consider the parthenogenetic process to be a possibility because they were quite
I see. So they thought
sold on the cloning process.
So found it by accident.
Yeah.
After the fact. Okay.
Yeah. But the most important point is Snoopy was verified as a clone. It is a clone, so Snoopy is okay. The two different papers were found to be fabricated, but Snoopy was indeed a clone. So after even during the investigation, Wang apologized for creating a shock and disappointment and tried to resign from his position as a professor in the university. However, Seoul University has rules that if you are under investigation, you can resign. You need to wait for the conclusions and then take responsibility of what you did. So only in 2006, the university suspended Wang after finding that indeed he was guilty in misconduct and ethical law violations. They also suspended 6 other faculty members along with him. And also in 2006, Wang was indicted on charges of embezzlement because he used the research fund for personal gain. So all of it together. And eventually the consequences, of course, Science Journal retracted both of his fabricated papers. Just as an interesting point, the Korean post office stopped selling post stamp showing Wang achievements, only to show that before that he had post stamps with his achievements. He lost the title of Supreme Scientist that was awarded to him beforehand. At the time, he held a conference and apologized for the old fiasco, but still he denied the allegations and insisted that human cloning was possible and that he had the technology to achieve it. And again, he was indicted of charges of embezzlement, but without physical detention. Since the controversy, he kept a relatively low profile, but he still works in the field. He works on a few international projects, one of which is the project of cloning mammoth
didn't go
in Russia.
Yeah,
after
George
a few...
Church in Harvard has a project because they are assembling chromosomes from, there are many frozen mammoths in Siberia and so on. So they extracted DNA, but it's broken. It's
that's what I read.
So that they are assembling the genome and then they will do cloning.
Okay. So still he works in the field. Now it is important to mention here, Wang did fabricated the result of human cloning, and up until now, as far as I could see, there is no evidence of human cloning. However, it
What
did.
do you mean there is no evidence? The Chinese guy did this like 3 years ago.
I don't know, but I think there were problems even in his research.
He went to jail, but the reason
no, he used something else.
No, not cloning. CRISPR-Cas9. Yeah, you're right. It was
he showed 3 different genomes.
Yeah, it wasn't cloned.
Yeah. Okay. So even though Wang fabricated his results and insisted in human cloning, even though there is no evidence for it, he still was a big researcher in the stem cell field and helped a lot to the field. And that's it. That's the story of the human cloning.
Right. So let's stop here just very briefly. Michal asked me, and she wanted to present 2 more very brief topics. So we'll do this. But any thoughts on one? Same, all same. You cheat, right?
No, it's interesting because it was actually a
good scientist.
So
people said that Sean was good scientist.
Bad work, you did some good works as well.
Yeah. That's what's crazy about it. You just want to be much bigger than what you are, and you end up missing everything.
At the end of the day, it's very proven. Somehow a fact of personality.
Yeah.
You have a big ego, and you won't deal with more.
Yeah.
And then it drives people nuts, and they are willing to go the extra mile to do all those things.
All of the cases till now we have considered, none of the person has committed that, okay, I genuinely committed that mistake. Nobody at all till now, whatever we have.
But
heard from
it's
you
again,
or whoever
it's
is
personality issue. If you are willing to do this, you are not going to. You're not going to oppose it. All right, let's quickly go through these other two topics.
Yeah, so those other two topics are one from my field of research and another one that a family member introduced me to, where the misconduct is a little bit different.
It's subtle, more subtle.
Yeah, kind of. Okay, so the first example is the problems of a slow refereeing process while in a race. So last week, if you remember, we started to talk about superconductors, so I'm going to use it for my example as well. Superconductors are materials that below a certain critical temperature show specific properties such as zero resistivity and perfect diamagnetism. Now, since the critical temperature is such an important property of the superconductor, there was quite the race to find the superconductor with the highest possible critical temperature. It is still on, but not as much as it was before.
Actually,
There's a big boost right now with the high pressure.
Yeah.
So personal recollection, I was a PhD student at the Technion at that time, and it was incredible. Every 2 weeks there was a new paper, few more, and it was really golden era in solid state physics because there was so much excitement, and everybody talked about applications, and it was very exciting time.
If you started to mention here, here you can see a picture of a physics convention in 1987, the Woodstock of physics. There was no place even to stand, and the convention took all the way to the middle of the night because there were so many
so you can see from 85 to 95 the green and blue. That was it.
Exactly. So you can't really see it here, but it's an article about the superconductor race heating up. So again, up until 1885 approximately, the critical temperature managed to get quite below 30 Kelvin, and the race was to get the superconductor with the highest possible critical temperature. Before the green dots you can see here are mostly superconductors of metallic alloys. And in 1986, George Norris and Alex Muller thought of the idea to check perovskites, which are a specific family of materials, and see if they are superconductors. And after playing a little bit with different elements, they indeed managed to find a superconductor with a critical temperature of 30 Kelvin, which was a step up. Now they wanted to share their results and publish it, but they had a problem. They could go to a prestigious journal, but they feared that during the long referee process, their chemical compound would leak. The fabrication of those superconductors were very easy. You only needed to shake everything together and put it in a furnace. So they feared that while they will publish the results, the chemical compound would leak. Another research group would duplicate the results and then publish it in a less known journal before them. So their conclusion was to publish in a less known journal. I'm not even going to try to pronounce it. There you go. And indeed, not many saw the results because it was a lesser known journal. Luckily for us.
Nowadays, there is a solution for that problem. Put it in archive.
Yeah, yes, you're right. Anyway, back then, and luckily for us, one of the researchers that did so the results was Professor Parul Chu, and he managed to replicate the results. And after further playing with different elements, he found another superconductors, which we call IBCO, and the IBCO showed a critical temperature of 83 Kelvin. Now, first of all, it was a huge leap in the critical temperature, and furthermore, it was critical temperature above 77 Kelvin, meaning that instead of cooling the sample with liquid hydrogen, that is helium, liquid helium, which is very expensive and hard to fabricate, you can change it to cooling with liquid nitrogen, much less expensive and much easier to fabricate. So a huge result. And again, Chu had the same problem, where to publish his results. If you go to a known journal, the chemical compound can leak and someone can steal his results, or to go to a lesser known journal. Now what Chu did, first of all, he rang the physical review letters editor and tried to convince him to publish his result without review. The editor declined, but after some negotiation, they agreed to give the paper to a referee that was agreed between both of them, which is, even that is highly unique. But still, Chu was afraid of the chemical compound leaking, so he submitted the manuscript after allegedly changing each yttrium symbol to ytterbium symbol. Instead of Y, YB, and submitted the manuscript like that. And at the last day that was that he could send the correction, he sent the correction, oh, not YB, Y, and it was published as such. Now, two things. The first one, the fake material happened to be a superconductor, which is quite a good superconductor, just not as good as the IBCO. And yeah, and the second point is that Chu fears were correct. Even after all those steps, the chemical compound was leaked, and suddenly a lot of research groups found and discovered superconductors with ytterbium. So quite a discussion arose. Is it misconduct? Pretty much yes. He submitted allegedly, knowingly fake data, but it happened. His fears came true. The data leaked, and his data was duplicated. So what could he do in order to publish his results? Yeah, pretty much, yes. Mm-hmm. Yes, so personally, I think this response. Mm-hmm. Yeah, so Chu claimed it was an honest mistake, but taking into account all the steps he did to avoid stealing his results, it apparently was with
let's switch to the last topic.
Yeah, and the last one is the grievance studies affair, or the so-called squared scandal, where three researchers deliberately submitted hoax paper to many peer-reviewed journals in the humanities studies in order to show problems in those journals and political influence in those journals. Now, during the hoax.
They did the research.
Yeah. Now, during this hoax, they submitted 20 papers. 7 of them were published in peer-reviewed academic journals. 7 were still under review by the time of the hoax reveal, and 6 were rejected. Between the ones that were accepted for publish were papers with the arguments that dogs engage in rape culture, as well as Adolf Hitler Mein Kampf, where they switched terms such as Jews and Germans with feminist terms, and it was accepted to publish. So, of course, quite the huge scandal, and many different polarized responses arose from that, some praising it to showing the problems in the field, some, of course, criticizing it as it is still a misconduct. They knowingly submitted fake data, and some criticizing the hoax itself, as it is not a good criticism of the problems, because the hoax itself didn't, it didn't follow scientific
there is a big deal. I mean, it's not legit at all.
Yeah, but still quite an interesting case.
It's a big part, it's problematic. Trying to deliberately do something like this. Yeah. Okay, so you succeeded, but it doesn't mean.
And you did exactly what other people are doing. You know. Great.
Yeah.
That's it.
Yeah.
Great. Thank you. Now we have AI tools. We can generate text with AI, which is very interesting. So you don't need to do this. You can actually write a paper and use AI. And shoot somebody. Guys, thank you very much. And we are going to meet next week via Zoom. And happy Hanukkah. All right, thank you.
Bye, everybody at home.
ביי.
תודה רבה.
ביי ביי.
ביי.
חבר'ה, שאמרו שהם צריכו לייצר חדר עם זהב, כסף